Hello, students. We're going to go ahead and get started on lesson 2.2 today. So we're going to be talking about angle relationships in this lesson. So to start us off here, we are going to see, I'm going to get all of my correct stuff here first. Okay, we're going to see an example of a warm-up problem here. So I'm going to use some terms that you've heard before and some that you haven't to go over some of this stuff, but it's a really good kind of look into what we're going to be doing. So it asks a bunch of different questions over here, but essentially the question is, can you find all of the different measures? So if we kind of dive into what you see in this picture over here, we should be able to notice some kind of relationships between these angles, I think is what I'm looking for here. So first thing I notice is this double little barred arc and this double barred arc. That means that those two angles are congruent to each other. So if this one's marked as 35 degrees, then this angle here is also going to be 35 degrees. And that angle right there is angle DPE. Okay, and it's congruent to angle EPF. So something we'll be talking about today in today's lesson. The other thing that I see is I see two other angles that are congruent to each other. Now, some people think since this one's a little further out than that one marking wise, that's different. That actually is just to show you that it's two different angles that are being marked. They're both marked with a single arc, and so therefore those two are congruent. So this is going to come into play in just a little bit. The last piece that I see in here is I see a right angle marker. So if you see a little box like this in an angle, you got to be very careful as to where it goes from and to, but it goes from over here to over here. So angle CPF, and what that shows you is that it's a right angle. So a right angle is equal to 90 degrees. And so at this point, what I see is that I know 35, I'm missing a piece, and those three put together should be equal to 90. So this is a part plus part plus part equal the whole scenario. So 35 and 35 makes 70. Take that away from 90 and you have 20 left. So I know that this angle right here is 20 degrees. I'm going to fill that one in as well. So then the last thing that you do is if you have a right angle over here and your APF is a straight angle, okay, or a 180 degree angle is what that one is there, so a straight angle, then your 90, if one side is 90, the other side is also 90. So this also has to be a 90 degree angle over here. And that's just simply because 180 minus 90 is 90. So if this angle over here, APC, is 90, and both parts of it are congruent, you just simply take your 90 divided by 2, and that's going to give you that each one of these angles is 45 degrees. So once you've filled all of that in, you could answer any of these questions. APB is shown in there to be 45 degrees. FPD, so if I go from F to P to D, that was these two put together, which was 70 degrees. APC is the one that we talked about to be 90 degrees. We will get back to this one. And then kind of angle BPD is, so BPD, if I add up 45 and 20, I get 65. So that's going to be an acute angle. So an acute angle less than 90, obtuse greater than 90. And that kind of comes back to what is right here. So all the obtuse angles. I'm not going to name all of them, but for example, one obtuse angle would be, for instance, angle APE. I'm just naming, I'm starting at A, I'm going through P, and then I'm going to go out somewhere. I could go to D, or I went through E here, but as long as it was greater than 90, that's what mattered there. So that's just a little bit of a warm up there just to kind of look at us talking about this vocab. We're going to get into these angle relationships now here, and the different types of angle relationships that we're going to have. So complementary and supplementary are the ones we're going to start with. These should not be new terms for you. So complementary angles, two angles that with measures that have a sum of 90 degrees. So we're going to add up to 90. That's what we want to think with complementary. And then supplementary angles, two angles with the measures that have a sum of 180 degrees. So your supplementary angles are going to form your straight line if they're next to each other. Your complementary angles are going to form your 90 degree angle or your right angle if they are next to each other. Now, I said if because it is very important to understand that you can have two complementary angles, these two angles right here, angle K and angle B, that are not actually adjacent or touching each other. So these two angles added together are equal to 90, and therefore they are complementary angles. Same thing goes with supplementary angles. These two angles here added together equal 180 degrees, and so therefore they are supplementary. They are not touching, they are not adjacent to each other, but they still are complementary and supplementary. Then they give an example of a complementary set of angles that does form a right angle. They are adjacent to each other, so they share side RS, and they form a 90-degree angle, and so therefore they've made a right angle there. And then again, an example of a pair of supplementary angles. So you have this 135 and this 45 that add up to 180, but they also happen to share a adjacent side, and they happen to form a straight line. And so that is possible in that case. So pairs of angles that are complementary or supplementary do not have to be adjacent. So we're going to use that term adjacent a lot. I always think of adjacent as your neighbor, but they do not have to be adjacent. Okay, so how does that kind of come into play? Honestly, it's going to come into play in more complicated of situations. So the difference between the measure of two supplementary angles is 18. And then it asks for the measure of the smaller angle and the measure of the larger angle. So it doesn't give you much, but it tells you the difference. So that means if I subtract two quantities, okay, between the measure of two supplementary angles. So what that means is that I'm going to have an angle. So one of my angles to be X, and the other angle in that case is going to be 180 minus X. Okay, so think about that real quick. If X is my first angle, all I know about supplementary is they add up to 180. So 180 minus whatever X is going to be my other angle. And so I'm going to put that into this problem. And so I'm going to say that 180 minus X minus X. So there's my two different angles put in there. And I made it easier on myself by putting the 180 minus X first. Okay. And that is equal to, it says that those are, so is the equal sign, and it says 18 degrees. So that's my setup to that problem. And then I have to solve. And so what happens in solving this, negative X minus X gives me a negative 2X. So I have a 180 minus 2X equal to 18. I would subtract 180 from both sides of this problem. So being very careful to follow my math here, that negative 2 does not go away. This is going to be a negative number. Do some quick math here. Is it 162? I'm going to check myself. Yes. So negative 162, and then I divide by negative 2. So dividing by that negative is going to get rid of that. And this is going to give me a total of 81. So my X in this case is going to be 81. Now it asks me for the smaller and the larger angle. I know that X is one of them. So 81 is one of the angles. And then 180 minus 81 then is going to be the other one, which comes out to 99. So to answer the question, the smaller angle is the 81-degree angle, and the larger angle in this case is the 99-degree angle. So that's kind of how complementary and supplementary might come about. The next term that comes up is perpendicularity. That's a fun one to say. But lines, segments, or rays that intersect at right angles are perpendicular. So angles are not perpendicular, but the line, segments, and rays can be. Okay, so segments or rays can be perpendicular to lines or other line segments and rays. The right angle symbol indicates that lines are perpendicular. So if you see that in a problem, you will see that right angle symbol, then that can tell you that you have perpendicular lines. You can also have a statement, which we're going to get to here in a second. So perpendicular lines intersect to form 4 right angles. So whenever you have those perpendicular lines, for instance, in this case here, we've got this one that is marked. There are actually more angles there. So there is a right angle over here is 90. There's one over here, and there's one down here, as well as the one that is marked. So there are 4 90-degree angles in this case. And it lists all 4 of those right here. Naming angles is very important. So angle, the first one that was here, angle AEB, is also the same. So just as a reminder here, angle AEB is the same as naming it angle BEA, but you cannot name this angle E. Okay. In this picture, for instance, angle E, there are 4 small angle E's. There's another 4 large angle E's, like 180-degree angle E's, and more than that. Okay. So you have to be careful with that. Now, perpendicular lines intersect to form congruent adjacent angles. Now, this may seem like a little bit, why do we talk about this? Of course, if they're both 90, then they're congruent and adjacent. This is something that's going to come into proof later on, where it just lets us, instead of having to say they're equal to 90 and then come back to saying that two 90-degree angles are equal, we can go straight to that idea. So just something to kind of keep in the back of your mind for right now, but we'll come back to that. It does give you good practice with writing congruent angles. You can see that right here. So naming an angle, writing them as congruent to each other there. Okay, so here's the symbol that I was just talking about. You can have the little box that's drawn in the diagram, or you can have this symbol written into something. So AC, segment AC is perpendicular to segment DB is how you would read this right here. And that will tell you that you have 90-degree angles. So if you see that symbol, you see anything about perpendicular, or you see yourself have a diagram with the little box in it. Both of those are ways to tell us that we have perpendicular lines, 90-degree angles, all of that kind of stuff coming up. Okay. So here's an example that we can look at here. Find the value of x and y such that PR and QS are perpendicular. So the way that they're going to ask things is sometimes they're going to say, these are perpendicular, solve. And sometimes they're going to say, find a value so that they would be perpendicular. It's really asking you to do the exact same thing. Okay. So for PR and QS to be perpendicular, what I want to look at here is that I want that 4y minus 2 then to be equal to 90, because that's how I would get a 90-degree angle in there. And I want that 5x plus 6 plus the 2x, I want those two pieces together to be equal to 90. Now, some people will try at this point to set these two quantities with the y's and x's together. You're going to get into a system that you don't need to get into here. So you want to try to keep the variables apart if you can. Okay. By adding 2 to both sides here, I get 4y equal to 92. Dividing by 4 then is going to give me y equal to 23. Just check my math real quick. Yep, it's going to be 23. So that gives me my y value. And then I solve with my x's and I figure out, sorry, I scrolled too far there. I'm going to combine. So I get a 7x. I'm going to subtract 6 at the same time, equal to 84. Divide by 7 then, and then you're going to get x equal to 12. So you've got your x and your y in that case, all based on the fact that we want them to be perpendicular lines. And so we had something that was equal to 90 there. Okay, so that's what came out of that. So that's perpendicular lines. Now, interpreting diagrams. So in geometry, figures are sketches that are used to depict a situation. They are not drawn to reflect total accuracy. So when I have said up to this point that no diagram in geometry is drawn to scale, that's what I mean. We do not draw it to reflect total accuracy. Some relationships can be assumed, but most cannot. Okay, so we're just depicting a situation. So this is a really good little section of information. Those of you that like to highlight stuff in your text, this would definitely be one of those things that I would highlight, because you're going to come back to it once in a while, depending on how good or bad you are at kind of knowing what can be assumed. So, and these are not exhaustive lists. So there's more that can be added onto them. But what can be assumed from a diagram? So when I draw something and you kind of look at what I've drawn, these are the things that you can assume by what I've drawn. So all points and lines shown are coplanar. Okay, so in this case, all of these points are coplanar. If I do not draw a physical plane on the paper to show that there is a point not on that plane, then everything is considered to be coplanar. So you can make that assumption. Okay, in this drawing right here specifically, G, H, and J are collinear. So you can assume collinear as long as they appear to be collinear. So for instance, you're not going to assume that G, H, and K are collinear because they do not look to be that way. But if I draw a point like G, H, and J are here to where they appear to be on the same line, you absolutely can assume they are on the same line. Okay, you can assume that these different rays intersect at H. So if you see a drawing and we have different figures that are drawn intersecting at a certain point, you absolutely can assume that intersection actually occurs at that point. So we're not going to pretend that this line just barely misses that H or something. That's not doable within diagrams. We make this assumption. Okay. You can assume betweenness. So because you can assume that G, H, and J are collinear, and because I have drawn H between G and J, then you can make that assumption that it actually is. So it's not like because of this drawing here that we could assume that H is somehow all of a sudden out here. Okay, I know that seems a little bit crazy to think that somebody would make that assumption, but that's exactly what we want to make sure that you understand. So you can make that assumption. Sorry, I'm trying to figure out how to get rid of that because I don't want you guys to keep looking at that. Okay, here we go. Okay, next assumption here. L is in the interior of an angle. So if you look at how this diagram is made, so they used MHK as the angle that's here. Okay, so if we look at that angle that's right there, you can assume that L is inside that angle. So it's not like you have that angle and then L all of a sudden could be, off to the side over here. If L appears to be inside of an angle, it is inside of the angle. And what that allows you to do is that you know that you have a part plus a part equal to a whole situation in that case if you have them in between. Okay. Again, just going to back up just a second. There you go. Then we have angles that are adjacent. So we used this word earlier, but we are going to use that quite a bit. So you can assume that angles are adjacent, that are drawn that way. So if they share a side, so the one they used here is GHM, so this angle over here, and MHL, so this angle right here, are adjacent to each other, and that's absolutely true. So you can make that assumption. You can also assume a linear pair. So this is actually an assumption of two other things, is that since you can assume adjacent and since you can assume collinear, then you can assume a linear pair. So you have these points that are collinear and you can assume that you have angles that are adjacent. So this angle here, and then imagine this all as one angle right there, if you can follow that. So GHM and MHJ, since you have these two angles that are adjacent to each other and they make up the line GHJ, then we can get to that linear pair. Okay. And then from linear pair, you can assume supplementary. Now, what you cannot do is you cannot assume that this angle 1 that I drew and this angle 2 over here that I drew are supplementary. There's nothing that lets you do that. But if they are adjacent angles that happen to be a linear pair, then you can make that assumption of supplementary. Okay. Now, that's pretty confusing. You're going to have some questions about what you can and cannot assume, and you're going to have to ask those questions as they come. Okay. What cannot be assumed, you cannot assume perpendicular. So none of these lines in this picture can be assumed perpendicular unless there is a perpendicular marking of some sort, whether it's the box or whether it's the upside down T in a statement. You cannot assume perpendicular. Angles that appear congruent may not be congruent. So just because like GHM and JHK look to be congruent, you cannot assume congruence. Same thing with segments. You cannot assume that segments that appear to be congruent are congruent. So segment GH in this picture and segment HJ appear to be the same length, but we cannot make that assumption. Okay, so those are the main no's there. Again, this is not a complete list, but this is a pretty good start to what you can and cannot assume. Okay, because points of intersection can be assumed, you can identify vertical angles from a picture. So we're going to be talking vertical angles here. Okay, if you look at, again, we have two segments that intersect at B, you can tell that, and then you can look at vertical angles from that. So the example that they give you here is angle ABD, so that's this angle out here, and angle CBE are vertical angles. So you absolutely can assume that those are vertical angles. We're going to be making some statements based on that. And also, just as a little bit of a reminder here or a look at this, is those two angles are actually congruent to each other. So your vertical angles are going to be congruent or equal to each other as you start solving. And then the last thing that you can see there is angle EBA. So angle EBA, if I follow that, that's this one out here. And angle ABD, so that was this first one that I did, form a linear pair. So you can look at that linear pair that's there, and you can know that their two measures added together are equal to 180 degrees because they form a linear pair. So we've got the linear pair equal to 180, and then we have the vertical angles that are equal to each other. So you have those two measures that are equal there. Okay. Be careful with your congruence and perpendicularity. Remember that congruent angles or segments and perpendicular parallel lines cannot be assumed. Okay, so be careful with those ones as you go through. Okay, so the last kind of big idea I want to do here is example 3, which is interpreting diagrams. Again, if you have a hardcover textbook, this will be filled out for you, but I'm going to go through it as if it's not. Okay, so determine whether each statement can be assumed from the figure. So huge figure here, lots going on. Okay, we read the statement. CE, ray CE, and ray CF are opposite rays. Okay, so opposite rays mean that they start with the same endpoint, which based on just the message that's here, I know that that's the case. And opposite means they go in exactly the opposite direction. So they're going to form a line if that's true. So ray CE is right here and ray CF is this way. And if you follow that entire thing, it forms a line. And so yes, this is true. Okay, and you have that common endpoint and they are opposite each other is what you're looking for there. Letter B, angle BGC, so BGC is over here, and angle KGC, so that's that one right there, form a linear pair. Yes, you can make this assumption here. We have a straight line from B to G to K, so that's going to be a 180 degree angle, and we have a common side right there from GC, and so therefore that's what you need for a linear pair. So that is also going to be a yes. I was going to try to figure out how to actually make that eraser work. Let's see if I can. Hey, look at that. I figured it out. Okay. Okay. Then we have, Oh, I don't want to select that. Okay, so then we have ABJ and CBG are vertical angles. So if we look at our vertical angles here, as long as they are, we can assume them. So ABJ is this angle and CBG, that's this one. So what I'm going to look for with vertical angles, I have a lot of people that have misconceptions about this, but I'm going to look to see if I have two lines that intersect. So ABC is one line and JBG is another line, and they absolutely do intersect at B, and those two angles are the ones that are opposite each other. So that is exactly what vertical angles are, and therefore the answer is yes. Okay. They're not adjacent, formed by two intersecting lines, and so yes, we have vertical angles there. Your next one, angle BCG, so that's this one here. We got to keep following these, and angle DCF are congruent. Okay, so if I'm looking at those two angles there, for them to be congruent, I think they'd have to be vertical angles or marked. They're definitely not marked, and they're not vertical angles because I do have one line right here, but to form the other side of it, I would have this one and I would have this one, which are not the same line there. So this one is going to be a no, and mainly just based on the fact that they're not vertical angles here is what you're looking at. Your next one is that segment BE and line IF are perpendicular. So segment BE and line IF. So is that a 90-degree angle? And the only thing you can say here, so here's the interesting part about this, is I can't really say that they're not, but I can't assume that they are. Okay. So in this case, remember the question is, can it be assumed? So the answer to this is no, that it cannot be assumed. But if you really read into that, I'm not saying they're not perpendicular. I'm just saying I can't assume that. Okay. Next one we've got our complementary angles, EBC and GBC. So EBC, let's see if we can find these guys too. Oh, my eraser just doesn't like me right now. So I am looking for EBC, and I think it was GBC, these two guys right here. I'm just going to check real quick. Complementary angles. Okay, so that would mean that they add up to 90. Are those equal to 90 degrees? That would also mean that we would have to have a right angle, which I don't have drawn and I cannot make the assumption of. And so just based on that, I can't assume that they're complementary. Again, I am not saying that they're not. There is a chance that they're complementary, but I cannot make the assumption that they are. Okay, ICH and HCD are adjacent angles. So ICH, so follow ICH, that's this one, and HC, helps if I do this, HCD, there we go. HCD are adjacent angles. Absolutely, they share a common ray. So one of their sides is shared, and that's exactly what you need for adjacent angles. And so yes, is going to be your answer there. Last one, BC is an angle bisector of ECG. Okay, so we're going to make some assumptions here. ECG, and so we have CA as the angle bisector. So is that piece congruent to this one is what you're looking for. Don't have anything that marks that, nothing that helps us get there, and so we cannot assume congruence, and so no, we cannot say that we have an angle bisector there. Okay, that's how that all plays out. Okay, so there's another set of assumptions that you can go through here just to really think about it. My suggestion is pause the video right now and try these out and then come back to the video, okay? So I'm going to go ahead and explain these now. So angle KHJ, that's this one up here, and angle GHM. Oh, that's fun. Let's see if I can reload that while we're here. We just want to have a fun little pause in the video. You guys can skip this part if you need to. We'll get back to it real quick here. Almost there. There it is. Okay. KHJ and GHM are complementary. So that would mean that they add up to 90 degrees. So sometimes these can be tricky because now I'm looking at this and I'm just thinking 90 degrees and I'm wondering if I have enough information here. So I do have a 90-degree angle right here. So KHJ and GHM. So I'm going to say no, that they are not complementary. So this is not something we can assume here because actually it would be that angle there with both of these angles over here that would have to add up to 90. So that's why we're going to say no on that one. Cannot make that assumption. GHM that's a big angle, and JHK are a linear pair. So this is a yes. You absolutely can make that assumption. Because both of those angles have a shared side, they're adjacent angles, they cover the entire straight line that's there, and the two other sides of them form a line, then yes, this is a linear pair. Okay. Ray HL is perpendicular to ray HJ. So I got to follow those HL and HJ. So not the ones I was hoping for. HL comes out to here. HJ comes over to here. I'd have to have a 90-degree angle between those two, and I do not. So this is not something that we're going to make an assumption on here. Next one, we're going to have GHM. Let's see if I can follow that one again. GHM, that's this guy down here. And MHK are adjacent angles. Yes, they share a common side. That's this side right here. And so they are adjacent angles. And then lastly, HL is perpendicular to HM. That's the one I was looking for earlier. This one is a yes right here. And I can only make that assumption because of that 90-degree marking that's in there. Okay, so it has that little box in there, and so we can make that assumption at this point. Okay, that does it for this video right now. Yeah, thank you.